Okay, Pre-Cal 12, let's get after it. Here we go. We're looking at the finale of our section on transformations, and it is combined transformations. So we've looked at this subtly, but again, we're going to look at everything being tied together in one action. So remember that when we have a transformation of a function, it goes from being y equals f of x to being all of this. So what happened to my coordinate point? So if our original point is x comma y, and I'm going to explain this on the next slide, we get a new point, and we'll call it x prime, y prime. So that's my new point. But what has happened to that new point is that my original x has been multiplied by 1 over b plus c, and then my new y value is my old y value multiplied by a, and then we add d. So a lot of questions I get is, why does this happen? Now, the y value is pretty intuitive, but we'll look at it anyways. The x value is a little bit more complex, and we'll look at that just to clarify things for you. So, reminder as well, you do reflections, compressions, expansions first. And why? Well, because if you look at the breakdown here, the reflections and the vertical and horizontal compressions and expansions are multiplication, and then the translations are addition. So if you think rules of bedmass, we do the multiplication and division before we do the addition and subtraction. Okay, so let's talk about these points. Now, the reason why the y point is more intuitive is because when you have your new y prime, this is your new y prime. Okay, and your old y prime was the f of x, right? Because y equals f of x. And this is still our old f of x. There's just stuff happening inside our function. So what are we getting? We're getting a times f of x plus d, but f of x was our old y value. So that's straight where that comes from. It's actually staring at us. It's that and it's that, because this part of my function represents the outputs of my original function. So that one's pretty intuitive. The tough one, though, is where does all of this business happening on the inside of my function turn into this? Well, as it turns out, in your transformed function, this in here is your new x, because the actions are happening on the new x at that point. This portion here represents your old x. So what you have is you have x is equal to b times x prime minus c. And in order to isolate the x prime, what do we have to do? Well, we have to divide by b and divide by b. So now all of a sudden we have 1 over b times x, because that's the same as dividing by b, equals x prime minus c. And then we just add c to both sides. And we get that our x prime term is equal to 1 over bx plus c. So that is why the 1 over b transformation is the confusing part, right? Because that is what's happening. So it was discussed with me with one of my students. It was quite interesting, so I wanted to throw it in here and show you if you're hoping to make that connection. If you're more of like, just remember what Herlar told me to do, then you can do that too. But here's the connection for you as to why those transformations occur. Now let's actually look at them in action. So here we have our original f of x function. It's transformed into this beauty right here. So we've had some transformations. Now, if the point 6, negative 3 is on my original, what is on my transformed function? So let's do this with the coordinates independently. So my original y value is negative 3. Well, what are we doing to that negative 3? If you look at this, we are multiplying it by negative 2, okay? And then we are subtracting 7. So our new y prime is 6 minus 7, which is negative 1. So this changes to, at least my y value for now, is going to be a negative 1. So now what do we do to my x value? Well, I have my 6. Now I am going to, remember, whatever we see here, we are multiplying by 1 over that. So multiply by 1 over 3, and then this says plus 5, but we are actually going to subtract 5, because original notation is x minus -5, right? So we are subtracting 5. The other way to consider it, I've mentioned, is what makes that 0 in there, and it's when x equals -5. So that's what we're doing. We are subtracting 5. So we end up with 2 minus 5, which is -3. So that is our new x prime, y prime. That's the new point on our graph. So let's look at another one. So in this case, we have 3 comma 2 is our xy. What is our x prime, y prime going to be? What's our new point? Well, first thing to look at is this is not in a form that I like. So I'm going to rearrange that so that my x term comes first. But then I'm going to factor out that -3, because we don't want to have a term in front of our x value. So this is the actual transformation that is occurring. So what is happening to this? Again, let's look at our y value first. Our original y value was a 2. We are multiplying it by -4. And then we are adding 1. So our new y value is going to become -8 plus 1. Our new y value becomes -7. Okay, so then what is happening to our x value? Well, for our x value, to get our x prime, we are taking our original x value, which was a 3, and we are multiplying it by -1 over 3. And then x minus 2 is already in the minus notation, so we are adding 2. So what do we get in this case? The 3's cancel. We have -1 plus 2. We end up with 1. So our new point is 1 comma -7. All right, let's do another. Now on this one, we have an inverse. So we have a new first step. So the first step here, we have -1 comma 2 is our xy. And we have the inverse function was our original function. So now it's saying, what is the transformation on the function that is not the inverse anymore? So our first step would still be to swap the x and the y, because now we are on the f of x function, not the f inverse of x. We've swapped. So in this case, we started in the inverse, so we have to swap back. So what do we do now? Well, we look at what is happening to our points. And in this case, we'll do this in one fell swoop instead of going a little bit at a time. Remember that your y prime is equal to ay plus d. So let's do that. We have the coordinate 2 comma -1. That's going to become, for my y prime, my new y value, my a is -3. So -3 times -1, and then plus d. In this case, d is -1, so plus -1 is -1. And then what about our x prime? Remember that our x prime was 1 over bx plus c. So our c value, in this case, we still need to discern. We're going to rearrange and factor out a 2, and we have 2, and then x plus 4, which is the same as x minus -4. So in this case, our c value is -4, and our b value is +2. So we are going to have 1 over, or sorry, our x value is 2 over, or times 1 over 2, and then we are going to add -4, or subtract 4. So we're doing it in one fell swoop here. Let me just rewrite this so it's a little cleaner. 1/2 times 2 minus 4. So we do that calculation. 1/2 times 2 is 2, minus 4, we get -2. And then -3 times -1 is 3, minus 1 is 2. And looking here, I just made a subtle error. 2 divided by 2 is 1. 1 minus 4 is not -2. Sorry, it is -3. So accidents happen, even to me. All right, so that's one fell swoop. using this information here that we just discerned, right? There's my new x prime, and there's my new y prime. This is also included in your notes as what's called method 2. So now let's just do one transformation on a graph, and what we'll do is we'll transform the individual points to create the new graph because it's a little bit easier than trying to do multiple translations, transformations, reflections to the graph over and over again. If we just determine the transformed point of the individual key points here, we can just then connect the dots on our new grid. So what are the original given points? That's always a good place to start. We have -1, 0. We have 0, 1. We have 1, 1. And we have 2, 0. So first off, let's do what's happening to all of our y values, because it's always easier to do the y value. So if we look at our y values, what's happening? They're all being multiplied by -2, and then we add 1. So in this case, 0 times -2 is 0 plus 1 will have a y value of 1. And then 1 times -2 is -2 plus 1 is -1. And then 1, if you notice you have the same number, obviously you're going to have the same transformation. And then 0, we're going to have the same transformation. So that actually makes our life a little bit easier. Now for our x values, what are we doing? We're multiplying everything by -1 over 2, and then we are subtracting 1, because here x is equal to -1 to make it 0, but also x minus -1, there's our c value. That's what we're adding. If we're adding -1, we are subtracting. So we're doing that to all of our original x values. So -1 times -1/2 is positive 1/2, and then -1, -1/2. And then we have 0, so 0 times -1/2 is great, it's still 0, and then -1 is -1. And then 1 times -1/2 is -1/2, and then -1 is -3 over 2. And then 2 times -1/2 is -1, and then -1 is -2. So we have the transformed points. They are at -2, 1. Watch the scale here on the grid. They are at -3 over 2, which is 1.5, comma, -1. They are at -1, comma, -1. And they are at -1/2, comma, 1. So again, watch the scale of the grid here. It's going to be different than the scale of the grid in your notes. And then if you're not sure if you connect your dots like this or the other way around, the best thing to look at is the reflection in the x-axis, because it means that your connected piece that was a horizontal line has been reflected into this side. So you know that you're connecting the bottom and that you then connect the diagonals. So that is transformation of a graph using specific points from the original. So there you go, combined transformations. We try to take the scariness out of it. I hope that helped, particularly determining the xy to x prime y prime, the algebra of it. I found that to be quite insightful, and I thank the student I was working with on that one very much. So thank you so much for watching. We're going to dive next into polynomials, section 3, so I will see you there.